Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Deck Machinery. Today we have 21st lecture and the topics are classification of air compressors, types of air compressors used on ships, pressure limit in single stage compressors, pressure ratios in multi-stage compressor, and limit on temperature rise during compression. In this tutorial, we will first learn about the classification of air compressors. Then we will learn about the types of air compressors used on ships. Next, we will learn about the pressure limit in single stage compressors. Then we will learn about the pressure ratios in multi-stage compressors. Lastly, we will learn about the limit on temperature rise during compression. Let's discuss these through the following slides. Classification of air compressors. Air compressors can be broadly classified into the following categories. Oil lubricated air compressors. Most of the air compressors equipped on ships use oil for lubrication of bearings and cylinder liner. Lubricating oil also prevents corrosion in the compressor. Oil-free air compressors. When air is used for control system, both the oil and moisture are undesirable and must be removed. Thus, an instrument air compressor is made oil-free, where bearings are lubricated by grease and piston has Teflon rings which have self-lubricating properties. Such compressors have dry crankcase and the main crankpin and gudgeon pin bearings are of ball or roller type, lubricated by grease. Split type crankweb is used for fitting and removal of crankpin bearing. Air-cooled air compressors. Air-cooled compressors are used on ships for small applications such as emergency air compressor, service air compressor, breathing air compressor, or deck air compressor. Air-cooled compressors have no corrosion or intercooler fouling, but run very hot and radiate lot of heat which require a special trunking. Water-cooled air compressors. Water cooling is preferred for large compressors which reduces carbonizing of lubricating oil due to low temperature of cylinder liner and valve cover. Earlier compressors were cooled by seawater which maintained low temperature but caused more fouling on the water side. Nowadays, fresh water is used for cooling the compressor jacket, cylinder head and cooling the air between stages. Fresh water is treated to maintain alkalinity and prevent corrosion. Intermittently operated air compressors. Most of the air compressors used on the ships for starting air are operated intermittently, thus cooling of the lubricating oil is not considered necessary. continuously operated air compressors. Deck air compressors usually operate continuously, thus the lubricating oil is cooled by air. Types of air compressors used on ships. Compressors can be broadly classified in two categories, mainly positive displacement compressor and rotodynamic compressor. Positive displacement compressors work by forcing the air in a chamber whose volume is decreased to compress the air. Once the maximum pressure is reached, a port or valve opens and the air is discharged to the outlet from the compression chamber. Common types of positive displacement compressors include reciprocating compressors. Reciprocating air compressor pump the air into a chamber by movement of the pistons. They use valves to guide the air into and out of the chamber. When the piston is on its downward stroke, it draws air into the chamber. When it is on its upward stroke, air is discharged into the air receiver. Reciprocating compressors used on the ship may be of the three types. Single stage compressors are sometimes used as service air for low pressure up to 7 bar, and they may have V configuration. Mostly two-stage air compressors are used for medium pressure application up to 30 bar. LP and HP pistons may either have inline or tandem arrangement. Three-stage compressor in VV arrangement is used for high pressure application up to 300 bar for refilling air cylinders of self-contained breathing apparatus. Screw compressor. Rotary screw compressors are positive displacement compressors which make use of two matching helical screws which guide air into a chamber whose volume is decreased as the screw turns. Screw air compressor may be installed in the engine room of a large ship for providing the deck air exclusively for maintenance purpose. Roots blower. Roots blower is a positive displacement air pump which has a pair of meshing lobes resembling a set of gears. Air is trapped in pockets surrounding the lobes and is carried from the intake side to the exhaust. It is used with inert gas generators equipped on product oil tankers for supplying the metered quantity of combustion air so as to control the oxygen content in exhaust gases. It is often used as vacuum pump on conventional oil tankers with centrifugal cargo pump for venting the oily vapors from their suction line. Centrifugal compressor. Centrifugal compressors fall under the rotodynamic type, which include both radial and axial flow compressors. Rotating vanes impart kinetic energy to the air and stationary passage convert velocity into the rise in pressure. Centrifugal compressors are equipped on ship's diesel engine and driven by gas turbine using the engine's exhaust gas. These compressors supply combustion air to the engine at pressure up to 3 bar. Pressure limit in single stage compressors. Purpose of single stage air compressors on ships. Single stage compressors are generally used for service or control air. Although service or control air on ships is usually obtained by throttling the starting air to 6 or 7 bar. Independent service air or control air compressors with single stage compression are also seen on some ships. Reasons for limiting the pressure rise in single stage. The reason for limiting the pressure on air compressors working with single stage is to prevent the explosion in the cylinder due to ignition of vaporized lubricating oil, similar to diesel engines. Maximum limit on the pressure rise in one stage. The single stage compressors thus have a pressure limit of 7 bar, above which air temperature exceeds the limit, which is 150 degree Celsius, resulting in carbonization of lubricating oil and causing fouling of valves. High air temperature also distorts valve components, which is kept within limits by cooling the cylinder and its cover. Pressure ratios in multistage compressors. Pressure ratios in multistage air compressors are in geometric progression. Geometric progression. A geometric progression is a sequence of numbers where each term is obtained by multiplying the previous term by a fixed number called the common ratio. Here the common ratio is G. So the sequence becomes 1, G, G square, G cube, etc. Usual compressed air pressure on ships. Ships are usually equipped with compressed air system having maximum pressure of 25 or 30 bar, employing two-stage compressors. Calculation of interstage pressure. Interstage pressure can be calculated by equating the pressures ratios of two stages as given below. So we can find interstage pressure P divided by inlet pressure Pi is equal to outlet pressure Po divided by interstage pressure P. From this we can obtain interstage pressure square is equal to inlet pressure into outlet pressure, or interstage pressure is under the root inlet pressure into outlet pressure. For 25 bar system, we can find the interstage pressure by multiplying 1 into 26 under the root. We have taken these absolute pressures and we are subtracting 1 after getting the result. So we get the value as 5.1 minus 1 is equal to 4.1 bar. Similarly, for 30 bar system, we can find the interstage pressure by multiplying 1 into 31 and taking the root and subtracting 1, and we get the answer 5.57 minus 1 is equal to 4.57 bar as gauge pressure for the interstage. Absolute pressures are used for finding the intermediate pressures and atmospheric pressure is subtracted to obtain the gauge pressures. Starting air pressure is reduced to 7 bar for use as service or control air. Limit on temperature rise during compression. Reason for temperature rise during compression. Compression of air results in rise of its temperature as the heat of compression is added to it. Rise in air temperature is also responsible for further rise in its pressure, which can be reduced by cooling the air. Compression process with least rise in temperature. As discussed earlier, isothermal compression requires least work of compression. Although it is impracticable, we still aim to approach it by taking away the heat from the cylinder and its cover, in addition to cooling the air after its compression before it is sent for further compression. Best cooling medium. Water is the best cooling medium to take away the heat of compression, though air cooling is considered in small air compressors. Specific heat capacity of water is 4.23 times that of the air, but water is able to remove 15 times more heat than air, as water molecules are much closer in comparison to air molecules. Seawater was used for cooling in earlier compressors, which has been replaced with freshwater cooling. Seawater caused frequent fouling of the system and was also responsible for corrosion, which required more maintenance. On the other hand, freshwater avoids all the above troubles provided the water is treated and maintained in alkaline condition. Nowadays, ships are equipped with a central freshwater cooling system, also known as LT system, whose heat is transferred to the seawater. This arrangement is helpful in reducing ship seawater system and associated corrosion-related problems, and greatly reduces the maintenance requirement of heat exchangers. Comparison between air and water cooling. Temperature of water is relatively less than the surrounding air due to its evaporation, which is dependent on the relative humidity in air. Air and water temperature are almost the same when air is saturated. As atmospheric air temperature is higher than water and its heat absorption capacity is low, air-cooled compressors are used for smaller application. Maximum temperature limit. Temperature of central freshwater cooling system is maintained at about 30 degrees Celsius, corresponding to seawater temperature of 25 degrees Celsius. When seawater temperature rises, fresh cooling water system temperature also increases accordingly, which results in high air temperature. A water-cooled compressor is able to provide compressed air at temperature between 35 to 40 degrees Celsius, and maximum temperature in the cylinder is contained below 150 degrees Celsius. This completes the study of classification of air compressors, types of air compressors used on ships, pressure limit in single stage compressors, pressure ratios in multi-stage compression, and limit on temperature rise during compression. This book is written by me and covers all topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ship's auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorial. I will be back with a new lecture shortly. Thanks for watching till the end.